guys, well, this is Striking Studies over here and welcome back to this channel. So now I'll be explaining Gravitation Part 2, which a lot of you have been waiting for a long time since I've uploaded Gravitation Part 1 last week or something. Okay, so let's start with the chapter. So in this chapter, first we will start with what exactly is centripetal force. So it's like, for example, if we take a child going around on a merry-go-round, the person stays on because they're holding tight to those bar in the middle. So basically, that's an example of the centripetal force. So you can just say that centripetal force is a force that causes acceleration and keeps an object moving along a circular path, acting towards the center. So in the absence of this force, the object will move in a straight line. So if the boy or the kid just leaves the merry-go-round, they'll just obviously fall back. And that's going to be like in a tangent to the circular path. So now the main topic of this part is free fall. So free fall, let's just first go to a thing which a famous person called Galileo Galilei, this is stupid. Never mind. That person said, in the absence of air resistance, all objects dropped near Earth's surface fall with the same constant acceleration under the influence of gravity. So, right now, the basic definition for free fall is mostly it's the motion of an object subject only to the influence of gravity. So an object is in free fall as soon as it's not in rest. Like if you throw it upwards and we ignore air resistance, and if we drop it down and then again we ignore air resistance, then it's in free fall. But only gravity should be acting upon that object for it to be in free fall. So now let's think about acceleration due to gravity. So the constant acceleration of a free-falling object is called acceleration due to gravity. It's denoted by small g. So this small g, acceleration due to gravity, is equal to gm by r square, where g is universal gravitation constant, m is mass of Earth, and r is radius of Earth. So, let's see. Acceleration due to gravity on Earth. So, on Earth, acceleration due to gravity is 9.8 meter per second square. So, if you want, you can check it out. So, universal gravitation constant, that is the capital G, is equal to 6.67 into 10 to the power minus 11 and meters per second. And the mass of Earth is 6 into 10 to the power 24 kg. The radius of Earth is 6.4 into 10 to the power 6 kilometers. So, the basic information on acceleration due to gravity. So, acceleration due to gravity is always directly proportional to the mass of the planet and inversely proportional to the square of the radius of the planet. Now, will there be variations in acceleration due to gravity? Yes. So the variation with height or altitude. So acceleration due to gravity decreases if you increase height because then the distance increases between the two bodies. Variation in depth. Acceleration decreases with increase in depth too. You would expect it to increase, but it decreases because acceleration is usually taken like the radius from the centers of the body. So if the body goes closer towards Earth, then there's still like a gap or something. And before I go to the third point, let's get this fact clear that the Earth is shaped like an orange and it's not a perfect circle. So the poles are a bit slightly bent, a bit more closer towards the center of the Earth than the equator or other sides. So that makes it that kind of explains why the acceleration is maximum at the poles and minimum at the equator. So then the fact of this video is if the Earth shrank half its current radius with its mass remaining the same, the acceleration due to gravity would be 4 times the original value. This is like more like a theory since you can't exactly shrink an object and keep to half of its current radius and then keep its mass the same. So it's like a theoretical fact. But anyways, that's the end of part 2. Bye bye guys. If you like this video, don't forget to smash that like button in the face. Subscribe and comment down below how this video was. Also, you may comment down below what chapter you want me to explain next. Bye guys.